Good morning, class. My name is Angela Archer, and today I'll be discussing the relationship between COVID-19, or the coronavirus, and ACE2. So first of all, let me just start by talking about the coronavirus. COVID-19 is the disease. Coronavirus, or it's also known as SARS-CoV-2, which stands for Severe Acute Respiratory Syndrome. It is in a family of viruses called coronaviruses, which is a very large family. In fact, the common cold is also a type of coronavirus. This was first documented, the coronavirus and SARS-2 was documented in late 2019 in China. It was believed to be originated in bats, which in turn infected small mammals, and which in turn these mammals infected humans. So, as we know, viruses are dead. All they want to do is replicate. They're not living. And just to give you a little idea of a coronavirus, what it's made out of, it has RNA inside of that coronavirus, and which is genetic material, stands for ribonucleic acid. Surrounding that RNA is a hard surface, and on top of that hard surface are little spikes, which gives the name corona or crown. These spikes are proteins, they're keys, and they are looking for padlocks inside a host cell. Once they find that padlock, they can get in and take over, replicate, and infect that host, that living being. So, and what's ACE2? ACE2 is angiotensin converting enzyme. It's responsible it serves several different functions in the body. It helps lower blood pressure. It also helps increase the glomerular filtration rate in the kidneys. So SARS-CoV-2, or corona, is transmitted through the air by droplets. It's also transmitted from a person perhaps touching a surface that might have been infected by the coronavirus, gets into the mouth, or you can mouth is transmitted by oral, mouth, nasal, or ocular eyes. Once inside the body, it starts to replicate. It's looking for the key. It's the key looking for a padlock. Well, those ACE2 proteins are abundant in the body, and as you age, we have more in our body, and they're found everywhere, in our hearts, liver, brains, thymus, blood vessels, kidneys, and lungs, and more importantly, in our alveolar tissue. And as you know, at the alveolar level in the lungs, that's where the carbon dioxide and oxygenation of the blood take place. So, once inside the body, that coronavirus finds those padlocks, and of course the ACE2 protein is the padlock. Gets inside and starts replicating. So, I want to also talk about ACE2 and angiotensin 2. ACE2 drives lung injury, by the way. ACE2 breaks down angiotensin 2. Angiotensin 2 also increases blood pressure, which in turn, this ACE2 breaking down the angiotensin 2 helps control blood pressure and blocks organ damage. And less ACE2, which can have increased inflammatory responses in the body. So the enzyme of the coronavirus blocks this ACE2, and at the alveolar level, it's really important because what can happen is the patient has those ACE2 proteins all over the body, heart, lungs, kidneys. So the patient can develop or develops an immune response. And with the ACE2 being now took over by the coronavirus, it can't break down the angiotensin II, which in turn increases blood pressure, which in turn increases the inflammation response and has the potential to increase organ damage and inflammation. One of the inflammation responses of corona is something called ARDS, which is acute respiratory distress syndrome. Sometimes a patient goes into this, and what happens is there's an increase in fluid and pus from the inflammation response at the alveolar level. So for instance, pretend this is your lung, and inside this sponge is little air sacs, or your lung, called alveoli, as I was talking about. With the immune response of ARDS, that lung becomes filled with fluid and pus. We'll say this bowl of water is pus and fluid. Well, the oxygenation cannot take place because the lung is filled with pus and fluid. The body can't get rid of carbon dioxide, and oxygenation cannot take place. So it's really important that the ACE2 is circulating in the body to help prevent this kind of damage. So that's why it's important to understand the relationship of ACE2 in our bodies and COVID-19, how COVID or the coronavirus acts on ACE2. That's all for today. Hope you enjoyed this short information series. Thank you. Can you leave her out of this?
No.
I mean, can you edit her out, I mean?
Edit her out? She's all over it. There's no way to edit her out.
I know.
It'll be kind of funny anyway.
I know, but I don't want to get in trouble. I don't want to get took off my cat being in the